Hello everyone, we are Group 4 from NextZ. Today we are going to present our project, which is AI-powered credential leak detection system. This is the version 2 release candidate developed under the supervision of Prof. Dr. Dery Fitrisari. So we are addressing a critical vulnerability in the education sector, as in with a massive 800,000 record breach at Columbia University. Universities are prime targets. Currently, we relies on reactive manual monitoring. This results in an unacceptably high mean time to detect, leaving our digital assets exposed for days or weeks. Our engineering goal was to bridge this gap with three objectives, which is automation. We built a continuous crawler targeting Pastebin and Tor to web proxies. Intelligence, we implemented a dual layer AI pipeline to filter false positives, and democratization, which we design a dashboard that translates raw JSON logs into visual threat intelligence for non-technical stuff. And this is our similar competitors, which is MIPS and recorded feature. So in the development methodology, we managed to this project using a hybrid agile methodology over a strict 14-week timeline. So on November 16, a critical engineering pivot occurred here, and we faced a blocker with dynamic content parsing, requiring a full refactor of our scraping engine during Sprint 3, which successfully cleared the path for our release candidate in December. And for the requirements, we define 4 non-negotiable functional requirements, which is discovery, privacy, latency, and security. And then
next is okay. So the next one is system architecture. To achieve this, we decided microservices architecture. The front end is a client-side rendered React Native application optimized with Flight. The backend is the Express API for high-performance asynchronous orchestration. Crucially, with the decouple the API surface into its own Python microservice, this ensures that heavy robot interference tasks do not block the main API event loop. Next. So this is the flowchart. So as you can see, there are front layer, backend service, and database, and many others such as API layer, and Pastebin, discovery engine, and many others. Next. So let's look at the discovery dynamic discovery engine. It operates on a specific workflow to handle scale. First, the scheduler pulls raw feeds. Then it hits our state store, a lightweight cache, to verify if the URL has been seen before, preventing duplicate processing. Finally, the targets enter priority queue, which automatically bumps URLs containing high-risk keywords like admin or password to the front of the line. Next. Okay, so next is our dual-layer intelligence. So first we have ingestion, which processes the raw text, and then we use PII masking for redaction to block out some sensitive credentials. Next, we use scoring from Roberta AI, and then summary from Gemini 2.0. Next. Okay, so for example, one is dynamic parsing. So the problem is that initial scrapers grab navigation bars instead of data tables on context-based sites. So to fix this, we refactor the logic to target specific table indices like the code next to that. Next. The next one, we have PII for the text challenge. So privacy was our strict constraint. We couldn't send student data to Google, so we built a custom PII master class. So standard reject failed academic domains. We tune our pattern to specifically catch multi-level TLDs like staff UIAC ID. So this ensures that rejection happens locally in the memory before any data packet leaves our internet network. Next. Okay, so to prevent NGINX timeouts during idle periods, we engineered a custom hook with a keep alive mechanism using a WebSocket heartbeat in that case. Next. Okay, so backend verification, we further this logic with rigorous testing using PyTest. So in this case, we achieve a 100 pass rate across 35 unit tests. This includes coverage for the scraping logic, the engine, and the API endpoints, proving the backend is stable and production ready. Next. So for deployment, we use the Docker Compose to orchestrate the environment. We run 4 isolated containers: front end, backend, AI service, and database. We use Docker volumes to PostgreSQL data, ensuring that even the container results, our intelligent database remains intact. Next.
Okay, so this is the next dashboard. We built this using React 19 and Tailwind CSS, and we implemented a glass morphism design system using backdrop blur filters. And this provides a visual hierarchy, allowing analysts to focus on the high contrast stats cards and the 7-day trend graph without distraction. This is the visual intelligence. There is a dark web page in the top right, and this component is directly subscribed to the WebSocket stream. The moment the variable critical count state exceeds 0, it triggers CSS pulse animation in red, and it forces immediate attention to new threads. And we optimize the analyst workflow by removing friction. Instead of navigating complex menus, we built a global command palette, and by simply pressing Command plus K or Control plus K, an analyst can trigger an asynchronous background scan for any domain instantly, and it is built for speed and efficiency. When the user click an alert, they won't just see raw text, and instead they will see a generative AI output. Our system processes the Gemini response to separate the summary from the mitigation steps. And this translates technical leak data into actionable advice, like to reset admin credentials, so that IT staff can act on immediately. And we verified the front-end reliability using Vitess for component testing, passing 5 out of 5 critical suits. And in our user acceptance testing, the client specifically rated the system almost complete for responsiveness, validating our choice of React and WebSockets. And for the future, we're already planning version 3.0. Our roadmap includes a WebGL 3D thread map for geographic visualization in Quartal 2 in 2026, and a full CM integration with Strong using standard syslog forwarding by Quartal 4. And in conclusion, Nexi transforms credential security from a reactive burden into a proactive advantage. It is automated, privacy compliant, and production verified. Thank you. And now we'll proceed with the demo. Yeah. Okay, so this is the landing page. Here the user can simply press initialize system, and then they will be taken into a page where they can choose between logging into an existing account or registering a new account. Since I've registered an account, then I'll simply log in with my account. And this is the main dashboard. Here we can see some status of alerts. Then we can see the dark web batch, the 7-day trend, and the recent alerts. Maybe I'll start from making a new scan. Here we simply put an already existing page. So this is an outdated page with leak data I found. We just simply paste and start scan. Here it shows that the scan initiated successfully. It means that the front end successfully sent the command to other services such as the scraping, which will the crawling and scraping, which will go to the pastebin URL and start scraping it. And then after scraping it, it will process it to the AI services. Then we can just load again. While we wait, we can do a quick scan. Okay, how does quick scan works? It will search for keywords such as ui.ac.id or student or at ui.ac.id on pastebin, and it will do a basic scan for the found leak data. Okay, maybe we can just reload. Okay, as we can see here, the new alerts. There are several new alerts 24 seconds ago. You can see, you can press view all, and these are the past leak data. We can click on one, and there's the AI score by Roberta. Source pastebin detection PII pattern match, and this is the generated alert information by Gemini 2.0. A summary, risk assessment, risk score of 85.7 out of 100, and Roberta rounds it to 86. Detected signals, email, password, ID, and this is the mitigation recommendation. Source, detection method, the AI risk analysis, detected data types, base content preview, and this will take the user to the leak data source. Okay, maybe this is the intelligent search, which allowed the user to search for all of the alerts and use the command or control key like this. Then quick scan now, settings, view alerts, search intelligence, and go back to the dashboard. And this is the alert list. This is the setting in which we can set the keywords for the quick scan. And here are some presets, ITB, OGM, or UI, the default. And here we can log out and choose between register or log in with another account. Maybe that's all for the demonstration. Thank you.